going to talk about domain and range, okay? We're going to look at different graphs. We're going to talk about this number E. E, Euler's number. Remember on Pi Day when we watched that video and it said Leonard Euler came up and he's the one that started calling it pi? We're going to talk a little bit about that number. Are we all right back there? Okay. I got concerned. Where are we? All right. I've got the power. So we're not going to do exactly what they say. They say cut these out and match them. It takes y'all like 9 years to cut stuff out, so just match, okay? Here's what I want you to do. Literally, it takes you 9 years to cut things out. And then, okay, so just match, because they're A, B, C, D, E, and F. So just figure out, you can use a calculator, or you can use an XY chart, or whatever, which of these graphs go with which of these equations down here, okay? We're not going to cut and paste. We're just going to match them. Oh, and then does it say... Oh, and then determine if it's a growth function or a decay function. What would a growth function look like? What would it do? It would grow, right? It would get bigger. What would a decay function do? Yeah, it's going to be less. It's going to get smaller, okay? All right, so do that. I'm going to give you a couple... So, f of x equals 2/3 x. Which one does that go with? A? Okay. Is that a growth or a decay? It's a decay. Okay. F of x equals 0.1 x. What does that go with? E? Is that a growth or a decay? F of x equals 10 to the x. F? Growth or decay? F of x equals 3 to the x. E? Growth or decay? F of x equals 1.5x. B? Growth or decay? Alright, so what about 1/3 to the x? Which one does that have to be? Growth or decay? A. Alright, what? Let me just ask you a couple questions that aren't in your book. Just a second. What do all of the growths seem to have in common? And what do all the decays seem to have in common? Looking at the equation. The decays are less than 1, right? They're positive, so they're between 0 and 1, but they are less than 1. And then the growth is greater than 1. Okay, good. Look on page 754. I'm going to leave this up so we can talk about the graph. Now we can look on 754. What point do all of these graphs have in common? 0, 1. They all pass through 0, 1 because what's anything to the 0 power? 1. And we're not adding anything to them or taking anything away from them. It's just a number being taken to a power. So they all go through 0, 1. And then we just talked about 2b. What do the equations of the growth have in common? The growth, what do the equations have in common? They're greater than 1. And what do the equations of the decay have in common? Less than 1, but not negative greater than 0, right. Okay. Alright, I'm going to move this page now. Let's talk about Sarah and Scott. They had to write a rule that would determine whether a function was exponential growth or decay based on its equation. Sarah got the thumbs up. Scott got the thumbs down. Alright, so read over them and tell me why Scott is wrong. Because he got a thumbs down. What did he say?
He says the decay is less than 1, but it's less than 0.
Right, because it's like negative 12 is less than 1, right? But it still has to be a positive, okay? Or even just look at 0. 0 is less than 1. Does it matter what power I take 0 to? No, it's just going to be a flat line the whole time, okay? So, look at this question. What b values in an exponential function, or in exponential function, okay, my number 4, does your number 4 look like this? Exactly like that?
No.
You have the y equals b to the x?
Yeah.
Okay. So, or f of x equals b to the x? So, what b would produce a neither growth nor a decay? 0 and 1. Right. 0 and 1. Because, again, any power you take 0 to is going to be 0. What about 1? It's going to be 1, right? Okay, good. So 0 and 1. Let's talk about number 5. Write an exponential function with the given characteristics. It's increasing, and its reference point is 1, 6. Which means if I put a 1 in for x, I'm going to get a 6 out. So, think about that for a second. If I'm going to raise something to the first power and the answer is going to be 6, what does it need to be? 6. Okay, so, f of x alright, b is decreasing, so that means we're looking at a decay. And we have a reference point of negative 1, 4. So I've got 2 hints right here. First of all, it's decay, so it's going to be a fraction. So if I put negative 1 and the answer ends up being 4, what did that have to end up, or what did that have to start out as? And what do you do with those negatives? You flip them, right? So what did I flip to come up with an answer of 4? 1/4. So this one would be f of x equals 1/4 to the x. Alright, C is a little bit tougher. So given us in behavior, so let's see if we can't figure out what's happening here. It says, as we go towards the negative side, we get closer and closer to 0. So this way is getting closer and closer and closer and closer to 0. But as I go towards the positive side, the graph goes positive as well. So it's like, basically it's doing that. So am I looking for a growth or a decay? It's a growth. I know it's going to be, b is going to be greater than 1. And then it says that I have to take something to the second power, and the answer ends up being 6.25. Something, I don't know, something to the second power ends up being 6.25. What's the second power of 6.25? Figure it out. 2.5. That's your answer. Let's try to get number 6's chart finished, and we'll stop with that problem for now. So we won't get to talk about E today. We'll have to talk about E tomorrow. Alright, so basic exponential growth and decay functions. What's the domain for exponential functions? What can I put in for x? Is there anything I can't put in? Yeah, so I could go from negative infinity to infinity on both of these. How about range? The y values. What do you notice about all of these graphs? Are they ever negative? No. They start at 0. They don't include 0, but they start there. And they go off to infinity. They don't include 0. 0 is actually, y equals 0 is actually an asymptote. They would like to get to 0, they just can't. I need to hurry and finish this chart, so give me just a minute. Intercepts, where do they always cross the y-axis? Yep. Okay, in behavior, as x approaches negative infinity, this one is approaching 0, and as it approaches positive infinity, it also approaches positive infinity. This one's just the opposite because it flips. It goes from increasing to decreasing. So as x is approaching negative infinity, this one is approaching positive infinity. And as x is approaching positive infinity, this one is approaching 0. It doesn't touch 0, but it approaches it. And this one increases, this one decreases. Alright, look at 10-2. You get that finished, look at 10-2 that we tore out today. 10 and 2. Next week we're not. Next week.
Well, it's next week we'll be in.
Alright, yeah, next week we're okay, we're going to go to number 18. Go to number 18. Yes, number 18. Yes. Oh, no, you don't, because that's E. No. Yeah, no, you don't have to do the vocab because that's E. Sorry. But go to 18.